Hi everyone, this is Russ King from Sierra Building Science. This short lesson is an example of the material that's in my book, HVAC 1.0 Introduction to Residential HVAC Systems, which can be purchased on my website, www.sierrabuildingscience.com, and is also available on Amazon. I call this lesson, Why a House is Like a Tank of Water. It is used to illustrate the basic operation of a home with a ducted heating system on a cold day. So let's pretend that you work for a big cattle rancher and he has asked you to install a big water storage tank to be used to water his cattle and fight brush fires. So you find a huge old used water tank and you have it set up where it needs to be. You run a long hose out to it and you fill it up with water. Now it is very important for watering the cows and fighting the fires that this tank be kept full at a constant water level at all times. It can go no lower than the level shown by the arrow. Unfortunately, the first thing you notice after you fill it up is that the old tank has leaks in it and the water level begins to quickly fall. Then you notice that the material in the tank is made of is not perfectly waterproof and water begins to seep right through the sides. You also note that the tank has no top on it and water is probably also evaporating out of the tank. While this is not nearly as much as the leaks and the seepage, it still contributes. You decide that the best way to keep a constant level in the tank is to install a pump. To determine how big of a pump to buy, you have to figure out how fast the water is draining out. Unfortunately, the rate at which the water leaks out is not constant. It changes with the weather. You do some quick calculations assuming worst case conditions and determine that the water is leaking out at about 10 gallons per minute. You go into town and find a store that sells pumps. They have pumps in stock that have capacities of 8, 10, and 12 gallons per minute. At first, you decide that the 10 gallon per minute pump is perfect, but you're not 100% confident in your calculations and you decide to buy the 12 gallon per minute pump. If you want the level in the tank to stay perfectly constant, you have to add water at exactly the same rate that it is escaping. If you add it too quickly, the tank will overflow. If you add it too slowly, the tank will drain out. Knowing that the rate at which the water escapes varies, you realize that you're going to have to constantly monitor the water level. So, you have a brilliant idea and decide to install a float switch. This float switch activates the pump. When the water level drops below the target level, it turns the pump on. When the water level gets back to the target level, it turns the pump off. Not wasting time to bask in the glow of your own brilliance, you hurry up and install the pump and the float switch and fire it up. Unfortunately, you were a little sloppy in your plumbing work and discovered that the pipe feeding the tank has leaks in it. It turns out that these leaks are about 1.9 gallons per minute. This means that the 12 gallons per minute that the pump puts out, only 10.1 gallons is reaching the tank. About a month or so later, the farmer gets his electric bill and blows a gasket. He says that your pump idea is way too expensive and that you need to do something right away. So what do? You figured that the reason the pump is using so much electricity is because it is running for so long. If you want the pump to run less, it has to fill the tank faster. So the solution is buy a bigger pump. That's right, we don't mess around out here on the ranch. Another month goes by and the rancher gets another electric bill, but instead of going down, it goes up. The rancher is furious and says that you have one more chance or you're fired. So you decide that maybe it would be better if the tank and the pipes didn't leak so much. So you tighten down the pipes, you put a cover on the tank to stop evaporation, you line the tank to prevent seepage, and you plug the holes to prevent leakage. Lo and behold, the total leakage drops down to 6 gallons per minute. You return the 12 gallon per minute pump and exchange it for an 8 gallon per minute pump. You install the smaller pump and the system cycles on and off nicely and the electrical consumption drops significantly and the rancher no longer thinks you're a hopeless city slicker. So by now you've probably made some connections between this tank of water analogy and a house, but I bet you didn't catch all of the subtle analogies, so let's review. The tank obviously represents the shell or thermal boundary of the house. The water represents BTUs inside the house. On a cold day, the BTUs inside a house want to escape. The water level represents temperature inside the house. If BTUs escape, the temperature drops. A house loses heat in 3 ways: convection, conduction, and radiation. The leaks represent air leaks in the home, or convection. The seepage through the side of the tank represents BTUs passing through the building shell, or conduction. Evaporation out of the tank represents radiant heat losses. The pump represents a furnace and the pipes represent the ducts. A furnace is simply a BTU pump that adds BTUs to the house as they are lost. The float switch represents a thermostat, which is really nothing more than a float switch measuring levels of BTUs in the house. Just like a float switch, it only has two modes: on and off. Determining the leaks in the tank and selecting a pump is analogous to doing heating load calculations and selecting a furnace. Thinking that the runtime of the system is what determines energy consumption is a very common mistake that many homeowners and far too many HVAC contractors make. Too many contractors are far too willing to sell someone a larger furnace rather than bringing in other contractors to address the inefficiencies of the building shell. Addressing the load of the house and fixing the building shell and reducing the size of the equipment, the runtimes, and the energy consumption represents the smart way of using building science and treating the house as a system. I hope you enjoyed this little lesson and learned something new. If you did, I think you will really enjoy my book, HVAC 1.0, Introduction to Residential HVAC Systems. Please visit my website at www.sierrabuildingscience.com. Click on Product Sales at the top, and then click on Publications.